Okay, so writing this out for gold or any other element with lots and lots of electrons is ridiculous. It really is. Yes, I'm going to make you do it, but it's really just a pain. So there's a shorthand or a shortcut for doing this kind of configuration. It's called the noble gas configuration. First thing you have to understand, or know at least, what the noble gases are. So the noble gases are in column 18 of your periodic table. They're the very last column. It's helium, neon, argon, krypton, xenon, and radon. And those noble gases are important because of the way they behave. They're not reactive. They don't react with anybody. And there's reasons for that, which we will learn about actually next chapter. But all you need to know right now is that the last column on the periodic table, the column 18, is called the noble gases. And what we're going to do is we are going to utilize those noble gases as kind of as marking points along the periodic table. And that's going to help us cut out a lot of what we have written here. So the idea is, if the noble gas, they're important because they're non-reactive, because they are all filled at a very special point in their electron clouds to make them non-reactive. They're good markers to use. So we're going to ask ourselves, well, if these noble gases are markers, what is the noble gas before the element that we're talking about on the periodic table? So we have to look at we have to look at an element we're talking about, or in this case we're talking about gold. We have to find the noble gas that is the atomic number before gold. And we can utilize that as a special marker. And then continue our electron configuration from that point forward. So I'm going to show you a screen recording of finding noble gases before the element given. And then we're going to come back and look at this problem. All right, be right there. Okay, so let's look at gold on the periodic table, which is here. And what we're interested in is the noble gas that is quote-unquote before gold. Well, gold has an atomic number of 79, so I need to go backwards, 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 keep going backwards. I'm at 55. I'm not at the noble gas yet, so I have to go over here to number 54, which is xenon. Because remember, this column, all of column 18, they're your noble gases. And they have a special reason for that, again, which we will learn in another chapter. Okay, so xenon is the noble gas before gold. So this could be done with any particular element. If we say we choose, let's say we say iron. We could ask ourselves, well, what noble gas is before iron? Well, iron is 26. I need a noble gas before it. So I need to go backwards, 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 and jump up a row to here, to argon. Okay? So those are our noble gases before an element. Now, some students, they'll accidentally say, oh, wait, let's go back to gold. They'll say, oh, gold, the noble gas is here because it's in the same. No. Because radon is after gold and has a higher atomic number, and that's not the case. That's not what we were looking for. We want the noble gas before the element. So I hope that's clear. Okay, so you can see from the video, from the screen recording, that the noble gas before gold is xenon. So instead of doing all of this, what we're going to do is I'm going to get rid of all of this. And I am going to start off this configuration with the noble gas that is before it. In this case, it's xenon. I'm going to put it in brackets. Now, xenon has 54 electrons. So that means I do not have to map 54 of the 79 electrons. I don't have to map it. And if that's the case, that means I have 79 minus 54 equals 25 electrons to map. But the question is, well, where do I start that next step to map those 25 electrons? Well, if xenon is atomic number 54, you're going to go to the next element. Well, number 55 is cesium. And why that's important to know is cesium begins the 6th row of the periodic table. And what you need to understand is that each row of the periodic table actually represents a major energy level. So I'm going to show you a little video on that and then come back. So check it out. So when we write the configuration using the noble gas notation, we have to, say we're using xenon. So I'm going to put that kind of just up here. So we are using xenon, and we're trying to get the gold. And xenon takes care of 54 electrons before gold's even reached. And so the question is, again, what do we go and start with here? What's the next step? Well, xenon is the end of the 5th energy level. And so when we go from 54, we go to the next electron, which is the next element, and we're going to go to 55. So after 54, we start 55. We start the 6th energy level. And so since after the noble gas, we start the 6th energy level, every time you start an energy level, it always starts with the S sublevel of that row. Because again, each row is the beginning of a new energy level. Everybody in this row is a part of the first energy level. Everybody in this row is part of the second energy level. Everybody in this row is a part of the third energy level, fourth energy level, fifth energy level. So as you go across a row, you've started that main energy level of that row. So going from, again, xenon to the next element would be cesium, 6th energy level. And of course, any start of any energy level is an S sublevel. And then you would go from there. You would follow your arrows and go, okay, well, 6S, and I got to get from 54, I got to get to 79. So I have a good amount of electrons. So 6S, 2, and then dot, dot, dot. And you'd finish up your configuration from there. I can do another example. Again, earlier we talked about iron. And the noble gas before iron was argon. And so if we were to talk about argon, which would start the configuration for iron, and we still have some electrons to go. So we go from argon, and the next element would be, from 18 to 19, it would be potassium, which is a start of the 4th energy level. And all energy levels start with an S sublevel. So we would start there with the 4S, and we can see we're going to fill in 2 electrons, and then we continue until we get to 26 electrons overall. So we'd have to continue that. So I hope that makes sense, and let's see how this applies to the rest of the problem. Okay, so each row in the periodic table actually represents a major energy level. And since xenon, in this particular case for gold, xenon represents all the electrons from number 1 to 54. So it represents all of that in the periodic table very nicely in this bracketed notation. That means we have to pick up our notation from the next electron, which would be cesium. And since cesium is the very beginning of the 6th energy level, we start at 6s. Because cesium, it's the first element in the 6th row. That means it's the first element in the 6th energy level, and all energy levels start with the S sublevel. Remember, S start, S start, S start. And once we know that, then we can pick up the configuration from that point. We can go to that guide that we had with the arrows and pick up from 6s the rest of the configuration. And so I kind of know this in my head, but you're going to have to follow those arrows. Maybe, hopefully you're smart. You wrote a copy of those arrows off to the side somewhere. So we're going to fill in 6s, 2. And then we're going to go to 4f, 14. And then we're going to go to 5d, 9. Okay. And that is our configuration. Because 54, 56, 60, 70, 79, we're done. We wrote all of our electrons in a much more compact form. Now, we can also do the arrow configuration like that, but generally we don't, because when we do the orbital configuration, we want to see all the orbitals. But if you were to follow this, I mean, heck, I have all this orbital configuration here, but remember, 1s all the way to 6s is covered by this bracketed information. So 1s all the way to 6s, so there's 6s, I can get rid of all the stuff before it. And so if I were to go and say, okay, xenon, 6s, 4f14, 5d9. Generally, though, we don't do this part. We only just do it with that. Okay? So utilizing the noble gas configuration is good. It saves you a lot of writing. But I'm going to tell you, you're only going to use the noble gas configuration if I explicitly ask for it. If I don't ask for the noble gas configuration, you got to write out the whole thing. Okay, so be aware of that. So I hope this made sense. And check out the practice, and we'll see you soon.